Our integrated literacy unit is designed for a ninth grade physical science course. The focus of our ILU is the history of the periodic table and how it came to existence. The book we are using is The Mystery of the Periodic Table, written by Benjamin D. Whitaker. The author takes the reader through the long and difficult journey of the curious minds that questioned the world around themselves and eventually led to what is considered to be one of the greatest scientific discoveries of all time, the periodic table. The book describes the many discoveries that had to be made to lay the foundation for the periodic table. The book starts with describing a time in ancient history when the belief was that everything was made up of four elements: fire, air, water, and earth. The belief lasted till the 15th and 16th century when Robert Boyle brought the idea of atomism to the scientific community, which was a large step towards the development of the periodic table. The author describes the process of discovering gases as the third state of matter, which was necessary to understanding observations made during experiments performed by greats such as Van Helmont, Becker, Cavendish, Priestley, Lavoisier, etc. The discovery of the third state of matter led to a greater understanding of the structure of matter in John Dalton's atomic theory. After Dalton's atomic theory, there was an information explosion about atoms, including their respective atomic weights. The information gathered on all the elements, most importantly atomic weights, seemed to be the key to organizing the elements. Many scientists created tables such as Dobereimer's triads and Newland's octaves, but only Mendeleev was able to organize all of the elements known at the time into columns and rows so that patterns of their properties emerged. The author describes the relentless process Mendeleev used in order to discover the periodic trends of the elements and his bold decision to include blank spaces in his chart for elements to be later discovered. Mendeleev's table was considered a success once the unknown elements were discovered and possessed all the properties Mendeleev predicted. Our integrated literacy unit will follow the processes and discoveries through history as we provide students with a hands-on experiences to relate back to their readings and how it connects to their lives today. According to Ohio's new learning standards for ninth grade physical science, all students are expected to understand the structure of atoms and the periodic trends of the elements. The following are the topics from the content elaboration on the study of matter we chose to focus our ILU on. Throughout our integrated literacy unit, students will be conducting individual research to create an informational book about an element of their choice. Each page in the book will correspond to a standard in our lesson and provide students an opportunity to apply and demonstrate their new knowledge.
Reading strategies are an important part of our ILU. One strategy we chose to use was a KWL chart. The KWL chart allows students to work both independently and with other students. Our students will fill out the K and W section, explaining what they know about the elements independently. Students will then share their charts in small groups of peers. As a group, students will pick one K and one W to write on different colored Post-it notes provided by the teacher. Each group will then take their Post-it notes and place them on the class KWL chart at the front of the room. This allows students to not only share with their small groups, but also the whole class. A biopyramid is also used in this unit. Utilizing a graphic organizer helps students organize information in the shape of a pyramid. The tiers of the pyramid are specific to where information is placed. The biopyramid allows focuses on using fewer words to help students understand how to effectively summarize information. The students not only pull out main ideas from the text, they are also able to make connections to the text. The biopyramid is also a good tool to use for review prior to assessments. Vocabulary strategies. As a way for students to learn the name of the elements on the periodic table, we will play Element Bingo. Each student will be given 2 blank bingo cards and a copy of the periodic table. Students will be instructed to write the symbol of the element on one card and the full name of the element on the second card. Students will be encouraged to vary their cards so they do not match other students. Writing the names of the elements and hearing names helps students make connections. A word splash will also be used. Students will be provided with a word splash to introduce new vocabulary. Students will look for words they do not recognize, find interesting, or may only know a partial definition. Students will be asked to try to predict the meaning of words using prefixes, suffixes, and other strategies. Students can work with peers to identify unknown words. Teachers will be circulating and checking on student knowledge and clarifying misconceptions as necessary. We like the way that the vocabulary words are presented differently in this strategy. Students can also help peers to develop meaningful definitions. Additional classroom experiences are important for student learning. During this unit, students will be performing laboratory experiments and activities. The experiments and activities allow students a hands-on approach to learn. Kinesthetic learning provides students a way to learn by doing, not just reading or listening. Students have the opportunity to be more engaged in their learning, and student interest increases with activities. This unit specifically allows for a lab for students to recreate the process Mendeleev used in order to determine the location of unknown elements on the periodic table based on their properties. Throughout the unit, writing activities will also be used. Writing activities provide the students an opportunity to demonstrate their knowledge through writing. Students will be writing a paper over a scientist who was a contributor to the periodic table. This writing provides a chance for research and practice for the students' informational element book. Further writing is done for the element book, which provides information on the history and characteristics of an element. Students will also demonstrate knowledge with an acrostic poem. Writing activities provide students with a way to respond to their learning and use higher level thinking skills. It is important for students to be evaluated on an ongoing basis. Students need to receive feedback to improve, and teachers need to know where students need further instruction. In our ILU, students will be assessed formatively throughout the unit. Entrance and exit slips will be used on a regular basis to answer questions students have and for students to demonstrate knowledge. A KWL chart will be used to show student progress during the units. Students will be able to fill in the L category during the unit to expand on knowledge gained. Our unit includes both individual and group work. During these times, teachers will be monitoring student progress through observations and discussions. Whole class discussions will also occur, where quick assessments can be made and instruction modified based on student learning.
Summative assessments for our ILU are diverse in terms of performance-based assessments and traditional teacher-created tests. The test is summative in nature due to it being completed at the conclusion of the unit. This summative test will be scored based on the number of correct responses to various questions on the content within the unit. The informational element book project and student writings throughout this unit will be scored based on a rubric and therefore are performance-based in nature. These types of assessments will allow students to demonstrate their knowledge and thinking. These performance-based assessments will provide students with the opportunity to play to their strengths and therefore increase student motivation and ownership of learning. It is our hope that through the use of multiple texts and diverse learning strategies, our students will have a greater understanding and appreciation for the periodic table, but most importantly, will have fun as they make connections with the content.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, kryptonium, and radium, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.